I've got good news and I've got bad news. The bad news is the footage of me disassembling my Akai GX-7 and most of working on the transport was lost in a hardware failure of my computer. The good news is I have the footage starting from when I was installing the idler wheel into the transport and everything that I did after that. So you're seeing this footage of the deck completed and back in my stack and running. I'm going to edit this video anyway. I tend to repeat myself, so I do reflect in some of the footage back on what I did before. So you do get some of that, but otherwise, sorry about that. I'm not going to take it apart again just to shoot the video, so it's just the way it goes. Okay, so I've been working on this Akai GX-7 tape deck on the transport. I've completely disassembled it already, re-lubricated the main cam wheel. So the only issue actually with this transport was with the infamous idler wheel. The fast forward and rewind basically were non-functional. This is the idler wheel in question. You can find these, you can find replacement tires for these. There's, I believe this is the common part with some of the Nakamichi decks. But I can often restore these without having to replace it. What I usually do is I use a product called Rubber Renew. First, I usually take the tire off, soak it in Rubber Renew, then let it dry for a day or two, put it back on, and then remove the outer layer with some sandpaper. Now, on an idler wheel like this, changing the diameter is not that important because it doesn't really affect the ratios at all. So as long as there's enough rubber to grip in the space that's given, it's not really a problem. So yeah, so using some sandpaper, just take off that outer layer to expose new rubber. And if it feels flexible to your fingernail, it's probably okay. Adding a little Rubber Renew doesn't hurt either. I also had to make a new spring for it. So I found that the spring that was in there, even after I used the Rubber Renew and got pretty good performance as far as grip, it was just way too much tension. The back of this wheel rubs up against a felt pad inside there, and that's how it provides a small amount of preload, because it swings back and forth on the arm. I can show this. This arm swings back and forth. That's the felt pad right there. So this turns and it kicks it over this way or kicks it over that way. To move this arm, there needs to be some preload, and that's what the felt clutch provides. But if it's gripping too much, it just kind of steals away some of the traction of the tire just to turn the tire in the first place. So I made my own spring using some piano wire. Tried a few different lengths and ended up with this size and length here, which provides more than enough tension to kick the arm over, but not so much that it breaks the wheel too much. I'm probably going to end up replacing this tire eventually anyway, but for now this will work. So here's some other areas of where I replaced the lubrication. Now these decks are pretty infamous for getting jammed up. There is a white lithium grease that they use here and also down here. These sliders move back and forth with the various positions, and this area here and that area there. The grease just turns into like a glue or a clay, and it can't move anymore. So I like to use this stuff for these types of things. It's just a multi-purpose synthetic grease. Stays where you put it. Has similar properties to lithium grease, not quite, but for low load type situations, it actually works pretty well. I've never had any problems with it. The cam gear, which is down in there, that is lubricated with this Moly based lubricant, like I said. The hardware on here becomes aware of the position of the cam based on this potentiometer here. I was not having any problems with this sensor, so I left it alone. I did give it a little bit of a deoxit fader F5 just for insurance. There is a window on this pulley here. I don't know if you can see that. It's right there. that window's not used by the electronics at all. The service manual talks about positioning this window relative to a spot on the chassis there, and the process is to when you're replacing this sensor. So there's no reason to worry about the alignment of that window unless you're trying to follow the procedure. Unfortunately, I didn't notice that when I took it apart. So if you do want to preserve this position, make sure that before you take this assembly apart, you find a home position, like at the end of the cam gear or something, and note the location of that window so that you can, when you put it back together, you can put it back in the right place. The manual does not give you any information about how to align that up properly for the gear down here. But like I said, it's not needed for anything. So the motor on these is actually built into the flywheel here, and then there's a belt that drives the other capstan, because this is a dual capstan type setup, because it's a 3-head. And yeah, so the only motors are this motor here, which drives the cam gear, and this motor here, which drives the take-up reels for fast forward rewind as well as playback. Yeah, that's pretty much it. The heads on this deck are in great condition. The pinch rollers are still pretty good. I give them a little bit of a treatment, but I don't use rubber renew on pinch rollers because it leaves that puts like an evergreen oil into it, which you don't want to get on your tapes. So I'm going to put this back together and test it out. And then the next step is to calibrate the electronics, which is another process for which I'll be using these test tapes over here. So yeah, when you're putting this thing together, the order that they go together for the idler wheel is first the idler wheel goes on. Move this guy out of my way. And this slides up and down. Make sure you have this spring in place that pulls up on this arm right there. Then you put the spring on. And then this little plate goes over the top of that. Goes with the bump sticking out. And you want to make sure that the two slots line up with the two little pegs on the idler wheel. And there's a small plastic bushing or washer. Mine was a little chewed up for some reason. Don't know why. Someone's had this apart before, I think. It's the first time I've taken this one apart. Sometimes it's tricky to get it over the little bump on there. There we go. Yeah, the slot that holds the snap ring, the E-clip, sorry. It's hard to get the plate past that, and then E-clip goes over that. Now, if you're ever going to work on tape decks like this or any other piece of equipment that uses these little E-clips, do yourself a favor, buy yourself a nice set of E-clips, because you're going to lose them. I've dropped a few of these over the years. Okay, there we go. One idler wheel. Now, I was going to mention in my previous section, you can access this idler wheel without taking the whole deck apart. You take this panel off, and it just kind of unclips, and you can swing it out of the way, and you can actually get in there with the deck all put together. It's not as easy this way, but it is possible to pull that off and replace the idler without tearing the whole thing apart. Another thing I want to point out too is when you're taking this apart, especially when you're taking these sides off, there's these little metal grommets that run through these guides. As soon as you take this off, these things will fall out, and there's one on the other side as well. When you're putting it back together, there's a lot of things to juggle. You have to align these two pivot points here, the two pegs on either side. There's also an arm in here that dampens the movement of the door. There's the spring that needs to detach right here, and there's also there's a peg on the inside of here. It's kind of hard to see. There's a black slider that moves up and down that does the power eject mechanism, and there's a little peg on the arm that's attached to this panel here. Make sure that the peg on that arm is on top of the little slider that moves up and down. Sorry, I can't get a good picture of it because the door is currently closed and I can't open it without powering it up. Okay, so I've got it partially reassembled here. Nothing is screwed down yet. Just got everything in position. All the cables are plugged back in. One really annoying thing about working on this transport that I forgot to mention is that all these cables are soldered on both ends. So you either have to desolder everything if you want to take it completely out, or you just have to kind of live with it. So I found a way to untangle the audio cables to the heads from this other mess and cut a bunch of these cable ties. And I was able to move it around enough that I could work on it. But when you do that, you're putting stress on all the joints as they enter the solder pads, so you got to be careful not to move it around too much. So let's see what happens here. I always plug my equipment into a variac, even though this thing's been powered up before, but variacs are really nice for bringing up hardware slowly, especially on vintage equipment with questionable capacitors. So let's turn my bench on here. Let's turn on the variac. And turn it on. It's a good sign. Turn it so you can see a little bit better. So let's see, I think this is the eject button. There we go. Power eject works. So this is that slider I was talking about before. Right here is in that position, and it needs, the little arm over here needs to be above the little tab on that. Otherwise it'll be backwards. Oh, there was another tricky thing with these brakes here. I just remembered. On the cam wheel, there's a arm that has to ride around the outside of the cam, and if it goes on the inside, these brakes will be pushing up against the take-up reels all the time. You'll know it's wrong when you put it together and you can't move anything because these brakes are on really hard. They shouldn't be. There should be, at best, just slightly spring-loaded. So let's see here. See if our idler wheel's working. Rewind. Pretty good. Fast forward. Not awesome, but pretty good. Playback. Seems good. Stop it. Stops. So it looks like our transport is in good shape. So now it's on to the electronic side of things. I used a little bit of the fader X on these sliders because they were a little noisy, and also the output slider here. This one was very noisy. One problem when you do that is it dissolves the grease that they use to sort of give these a nice smooth feel. So now they feel kind of cheap, but you can always reapply a little bit of silicone grease on the outside of the rails right here if you want to bring back that smoother feel, which I'll probably do. So I kind of like that. So yeah, next step is calibration. Okay, so here we're using a mirror cassette to verify the transport alignment. You can see through the mirror there, that's actually the back of the pressure pad. The erase head is there, the record playback head is right there, and there's a guide right here. So the manual says to turn the adjusting screws, or nuts rather, to align those. So you don't see any tape in there right now because we're on the clear leader, so if I hit play, you'll see the leader end right about now. There it goes. So ignore the alignment of the pressure pad, it's kind of loose in the tape there, so we just have to look closely at the tape on the erase head over here, and you're looking for the same amount of head showing up on either side of the tape. The guide over here, you want to make sure that the tape is centered in this guide. There are little bumps on either side, and if the tape is rubbing up against them, it'll actually curl the edge of the tape and stretch it. It looks like I need to make an adjustment. You can see it kind of curling right there. And then finally you look at the head itself, and it's a little more tricky, but you're looking at the cores. You can't really see it in this image all that well. There's an adjustment nut over here, and there's another one. It's actually over here. So here's the tape, the alignment cassette playing after I've aligned it. There's 3 screws on this one. There's one there, one right above it, and then one over here. So the 3 screws adjust both the position of and angle of the head in every direction, and when you start turning those screws you can get yourself into trouble real quick. So it's important to keep the head square to the tape while also aligning it with the tape's position while also aligning the azimuth. So it can be a bit of a challenge. We're going to set the tape speed now. This is the tape that I use for that, 3 kilohertz flutter and speed test. You just play these, you never rewind them. Puts out 3 kilohertz. That looks pretty good. I'm seeing 3.046. Kilohertz. Alright, tape speed set. So here are the 3 tapes that I switch between. That's the mirror cassette. This is a 3-tone test tape, 10 kilohertz, 1 kilohertz, and 63 hertz at minus 10 dB. And this is just a 10 kilohertz tone at minus 10 dB as well. These ABEX tapes are really nice, so if you find those, grab those because they have the most quality as far as the recording on the tape. This Sanyu tape is a little inconsistent, but the reason I got it was just so that I could have a steady 10 kilohertz tone when setting azimuth. It's a pain when the other one's switching between 3 frequencies all the time. So yeah, I play back both of these tapes at 10 kilohertz just to kind of cross-check each other because these are not technically azimuth tapes, but they're pretty consistent with each other, so I'm just kind of using those to set my azimuth. I switch between those 2 and then I go back to the mirror tape, make sure that it's still aligned. If not, I adjust as needed, then go back to these 2 tapes, get the 10 kilohertz to sound the loudest and most even, and back and forth. And then when I'm done and I think I have everything good, that's when I throw the meters on it and actually double check. But usually with a pair of headphones in my ears is enough to do the job reasonably well. So the final test of the head adjustment on this tape deck is to record a 10 kilohertz tone at a low frequency and play it back. Now since it's a 3-head deck, I can play it back while I'm recording it, and I had no signal at all on the right channel. I traced through the circuitry following the frequency through, and everything looked good on the electronic side, so I started looking at the head, and sure enough I measured the resistance of the heads and it was wide open on the right channel. There was no connection. So I thought maybe I had a bad head, which was a bummer, but actually I just reflowed the solder joints on the head there and it's working. It's something you should always do after using tools near your tape heads and tape transport is to demagnetize. Probably should have done this earlier, but I sort of forgot. So you slowly approach with the demagnetizer. Don't want to make any sudden movements or else you will leave a magnetic field on what you're trying to demagnetize. And you just want to touch the tip all over the head. Slowly move to the erase head, capstan. Never want to make any sudden movements because it will leave a magnetic field that you may not be able to remove. You slowly pull it away. Okay, it's time to set the playback level. This can be a chicken and the egg process if you don't have the exact tapes that the service manual requires in order to follow that procedure. But there is a workaround that you can do with one special tape, that if you get this tape right here, and you're working on a cassette deck with Dolby, you should always be able to set the playback amplifier to the exact correct level, and then once you do that, you can then set the meters to adjust them so that that level is hitting the Dolby symbol on the meters, and you will have a correct playback gain and meters. So what you have to do is find the data sheet for your Dolby chip. In my case, it's the 652, which is pretty common. It was used on the Akai decks that I have. The spec for that specifies that on a certain test point, I should see 387.5 millivolts. Now, that test point in the schematic they provide is when you're using the companion 654 chip, but this deck does not use the 654. It only uses the 652, and the rest of it's done discretely. The 654 is like a routing chip, and they're doing it all discretely on this deck because this is a very nice deck. So a little bit of interpolation is required, but looking at the schematic, I know that that same test point that they show in the data sheet is also looping back to pin 1 on the 652. So all I need to do is measure the AC voltage on pin 1, and I'll be able to set the playback gain to my reference here. So I'm going to set the reference to 387.5 volts on pin 1 of the 652 Dolby chip using the reference tape. So I'm using my scope here to give me the RMS reading. So on the right channel I'm getting about 640, or sorry, 340. Pretty close. These are not precision trim pots, so it's pretty tough to get it exact. You just kind of have to do the best you can. There we go, 387-ish on the right channel. So now let's check the left channel. Pin 1. This one's 387.5. This one's right on. So it was just the left channel that was, or the right channel that was a little bit off. So now if we look at the meters, I haven't adjusted the meters yet. I just adjusted the gain on the one channel there. But you can see they are right on the Dolby symbol there. I'm just going to give them a tiny little tweak. You can see the left is just flickering, which is right where it needs to be. And the right's maybe a little bit high, so I'll turn that one down to make it the same. Okay, so the next step is to set the recording bias on this deck. It's a fixed bias deck, so the adjustments are only internal. So I just pick a tape that I have around that I like to use as a reference, and I adjust for that tape. You have to feed in two frequencies, usually 10 kilohertz and 1 kilohertz, and then you adjust the head bias until both frequencies play back at the same level they're recording at. And because it's a 3-head deck, it's really simple. I just start recording and monitor the tape, and then look at the output levels coming in as I switch between the two different frequencies. So 3 is already really close. Pretty good. Switch to the left channel. There we go, 81.5. So you're kind of chasing a convergence. They're both responses are changing, so you just got to try both directions and see if they're getting further apart or closer together. And once you get them kind of as close as you can get them, then that's it. Equalization set for this type of tape. Most decks have a left and a right for the normal bias, but the chrome Type 2 and the Type 4 adjustments are for metal tapes are usually just a single pot. So my reference tape for chrome is going to be a Maxell XL2. I have lots of those. Always make sure you're using a good tape, not a worn out tape. High frequency is a little hot, so turn it down a bit. Pretty close. Switch to the other channel. Yep, looks good. And for metal, I'm also going Maxell MX90. Honestly, I don't know if I'll ever really do much recording with this deck, but since I'm in here, there we go. Verify the other channel. Not that I can do much about it. Yeah, so here I'm seeing a little bit low on this channel, so I just kind of split the difference. It's pretty good. And that's setting the record bias for all three types. Okay, now we're setting the record level. You just feed a signal in from the signal generator. I'm generating 1 kilohertz here. You set your record level to some level on the meter, which you know you calibrated from the previous steps, and you record that signal. And then you see, since I'm playing back the tape, it's a 3-head deck, I can see that it's like a couple dB low. Just like 1 dB low. Switch back and forth between tape and source here. So now we just need to set the record amplifier so that we're actually getting 1 dB onto the tape. Because this is a 3-head deck, it's much easier than on a regular cassette deck. So you don't have to record, rewind, and then play. Alright, record level set. So just to show what I mean, that's the tape playback and that's the source. 0 dB, playback 0 dB. So it was a little low before, so I turned up the record gain so that it's actually putting 0 dB onto the tape. Alright, so I've made it through the whole calibration process. I didn't have any issues. I looped back and checked the playback levels and they were fine. Check the transport again, it's all good, so this tape deck is ready to rock. Alright, so the tape deck's all put back together, servicing is done, let's take it for a spin.